All right, 7.4 multi-step triangle problems. So we look at 1 through 6 here. We're talking about area, but they've all got a side length missing that is needed to find the area. If we look at 7 through 12, this is going to be using special right triangles here. And we have two triangles smashed together, and we're going to have to find the side that they share, but we'll get to that in a minute. So starting off with number 1. If we read the directions, it talks about rounding your intermediate values. If you just round at the very end, or you can round in the middle, it doesn't matter. You might have to round a little bit extra if you don't round in the middle, if that makes sense. Number 1. So we're supposed to find the area. Area is 1/2 base times height. Here's your base, and here's the height. So the thing is, we don't have the height in this one. We're going to have to use the Pythagorean theorem to find it. We cannot use special right triangles here because we don't know these angles. If you don't know the angles, you have to just use the plain old Pythagorean theorem. So I'm going to call this x, and I'm going to say, well, x squared plus 8 squared equals 11 squared. So x squared plus 64 equals 121. If we take 121 minus 64, we get x squared is 57. So x equals root 57, and it talks about rounding here. So we're just going to type in root 57. We don't have to rationalize, or simplest radical form. I'll say 7.55. Yeah, we'll say 7.55. So this is 7.55 there, and we can now plug into our area formula. Area is 1/2 8 times 7.55, so 4 times 7.55, and since mine is still stored there, I'm just going to multiply by 4, and I got 30 point, we'll say, what should we say there, 30.20, and I don't really care about units here, so let's say that. Oh, it said 10th, so I guess I don't need the O there. All right, number 2, same process. We're going to start off by finding our x here. So we're going to say, well, x squared plus 5 squared is 12 squared. So x squared plus 25 is 144. X squared is 144 minus 25. $119, and x is going to be we'll say 10.9. So this side here is 10.9, so our area is going to be 1/2 5 times 10.9. So I'll say 0.5 times 5 times 10.9, 27.25. And it said around the 10th, so we'll say 27.3. All right. Number 3. This one's going to be a little bit different. Here's our height. Here's our base. We have this right side of the base. We need to find the left side. So we'll call it x, and we'll say, well, x squared plus 8 squared equals 11 squared. So there's a little bit of a faster way to type this in our calculator, and I'm going to show you it now. So we'd say x squared is 11 squared minus 8 squared. So x is root 11 squared minus 8 squared. And I think the value in this is that you can just type the whole thing in all at once. So I'm going to say root 11 squared, there's a square button, minus 8 squared. So x is 7.5 We'll just say 7.5. So this is 7.5. So the whole base, how do I want to write that? The whole base is going to be, what is it, 7, 8, 9, 10, 10.5? 10.5. So we'll say area is 1/2 10.5 times 8. So I'll change that to 10.5 times 4. 10.5 times 4 gives me 42. All right, there we are. Number 4, similar situation. We see that here's our height, and we are missing this piece of the base. Now there's a little bit of a trick to this one that you can do. If triangles have, oh, can we do the trick? You know what? We just won't do the trick. I don't know that we actually can. We need to find our height here. We'll call it x, and we'll say, well, 10 squared equals 6.2 squared plus x squared. Let me rewrite that a little bit and say, well, x squared equals 10 squared minus 6.2 squared. So x is root 10 squared minus 6.2 squared. And whenever I type that in, root 100 minus 6.2 squared, I got x is 7.8. So this is 7.8. And we could kind of think about this. If you flip the triangles over, say you used this as your hypotenuse and this is your other side, well, it's going to have to be 6.2 here. So you could do the Pythagorean theorem again, but that has to be 6.2, and that's the shortcut I was talking about. So our whole base, if we add these together, is going to be 12.4. So our area formula is going to be 1/2 12.4 times 7.8. So 0.5 times 12.4 times 7.8. So 48.36. And whenever we round to the nearest tenth, we get 48.4. All right. Number 5, similar situation. It's kind of reflected over. We have to find this side here. So I could say, well, I'll call it my x. I'll say I've got x squared plus 6 squared is 8 squared. I think x is going to be 10. I'm going to write that down just to check myself. So x is going to be root 8 squared minus 6 squared. No, how did I not do that right? Oh, that's because the 8's the hypotenuse. Oops. All right, so x is 5.3. So this is 5.3. Now we look at our left triangle here, and we need to find the base there. And unfortunately, we're not going to be able to use a trick like we did in number 4. So I'm going to have to say, well, 5.3 squared plus, we'll call this y. Y squared equals 6 squared. So y equals root, we'll say 6 squared minus 5.3 squared. And I got y equals 2.8. So my whole base, we'll say area equals 1/2 base times height. My base, the whole base is going to be 678.8. My height is 5.3. So I can say, well, area is 1/2 8.8 times 5.3. So whenever I type that in, 23.32, which gives me just plain old 23.3. All right, number 6, last one. Same situation, we have to find our height, and then we're going to be able to find our base. I'll find this one using orange. I'll say, well, that's x. I'll say x squared plus 11 squared equals 15 squared. So x is root 15 squared minus 11 squared. All right, and x is 10.19, or we'll say 10.2. All right, to find the base there, I'm going to say, well, we'll call it y. Y squared plus 10.2 squared equals 11 squared. So y equals 11, root 11 squared minus 10.2 squared. Let me see if I turn off projector mode. Maybe that'll make it work better. Root 11 squared, oops, that's not what I wanted, minus 10.2 squared. Y is going to be 4.11. So right here is 4.11. So let's do our area formula. Area is 1/2 base times height. The base added together is going to be, what is that, 15.11? Or we'll just say 15.1. And the height is going to be 10.2. So 1/2, 10.2, 15.1. And I got 77, and we'll say just plain old 77 because we're rounding to the nearest decimal point. All right, there is number 6. All right, the rest of them we have to leave in simplest radical form, and I think these are really neat problems. On all of these problems, what you're going to want to do is you're going to want to find the side that they share. So you could even go through all of these and you could highlight the side that they share. And we know that that's going to be the first step of the problem. So number 7, we're given the 7 up here, and we want to find x down here. If we look at the top triangle, it's a 45, 45, 90 triangle. 7 is the hypotenuse, so I know that the leg here is going to be 7 over root 2. I used my, what did I use? I said leg equals hypotenuse over root 2. And what's normally a good idea with these problems is to rationalize at the very end. Don't try to rationalize in the middle, because a lot of the times, like it's going to happen in this one, stuff will cancel out for you. So now we look at the bottom triangle. 7 root 2 is our hypotenuse, and we need to get our leg. So we're going to use this formula again, and we say, well, that's 7 over root 2 times root 2, or just 7/2. All right. I know that a lot of this work you end up doing, or I ended up doing in my head. I think that's kind of the way to try to do these problems. You're welcome to write them all out, kind of like what we did for the regular special right triangles. But I think it works a whole lot faster if you can start doing the doing those computations in your head, or doing those formulas in your head. Number 8, very similar setup, right? Very similar setup. So I look at this guy. He's going to be 6 over root 2, because I went from the hypotenuse 6 to the leg. And now my 6 over root 2 is my hypotenuse, and my x is a leg, so it's going to be 6 over root 2 times root 2, which is 6/2, which is 3. All right, very similar setups. All right, now we have 30, 60, 90 triangles, so it changes it up just a little bit. For starters, let's look at the bigger triangle here. What I'm given is the hypotenuse, and I want to find This is in the blue triangle, it's the short leg. To get from the hypotenuse to the short leg, what do we do? I believe that the short leg equals the hypotenuse over 2. Let me double check. Yes, yes. All right. So my short leg is right there is going to be 4, right? 8 divided by 2. Now let's look at our green triangle. In our green triangle, we're trying to find the short leg, and we aren't given the short leg, we're given the long leg, right? In this scenario, you look at the green one, the 4 goes to the long leg. It kind of changes it up a little bit. Well, we know the formula to get from long leg to short leg. The short leg is equal to the long leg over root 3. So I'm going to say, well, x equals 4 over root 3. And unfortunately, I'm going to have to rationalize that. It's going to be 4 root 3 over 3. All right, there we are. I know that one's a little bit longer. We'll do a few more like it. Number 10. So we start off the 9 root 2. That is our long leg. And we want to find our hypotenuse. And now I'm going to have to erase the hypotenuse in a minute, but we'll leave it there while we get there. So to get to the short leg, you're going to take 9 root 2 over root 3, right? The short leg is the long leg over root 3. The hypotenuse is the short leg times 2, or 2 times the short leg. So this here is going to be 18 root 2 over root 3. Right? Now we're no longer going to talk about this being the hypotenuse. We're going to look at this triangle here, and that is now the long leg. We're going to go back over here, and we're going to say, well, the short leg is the long leg over root 2. I'll call this y for the sake of work. So y is going to be 18 root 2 over root 3 and another root 3. So that's the same thing as 18 root 2 over 3, which I believe can simplify down. What is 18 divided by 3? Oh my goodness. 18 divided by 3. 6. Okay, that makes sense. We got 6 root 2. Now this is our short leg. Our x, our hypotenuse, is 2 times the short leg. There we are. All right, number 11. This one again, we're going to be trying to find this side to start off with. We're given the long leg, we're going to have to find the short leg, and then we'll find our hypotenuse. To get from the long leg to the short leg, you divide by root 3. So I'm going to have 6 root 6 over root 3. And you can actually combine roots over a fraction bar. Right? This is going to be 6 divided by 3, which is going to be 6 root 2. Right? Yeah. Now our hypotenuse here, that's going to be 2 times the short leg. And now we actually, I don't know if I talked about this yet, but this was a 30, 60, 90 triangle. This one down here is a 45, 45, 90, which actually makes it a little bit easier because then we just have to multiply by root 2, right? This is our hypotenuse, and this is our leg now. So my x, I'll change colors here to blue. X equals 12 root 2 times root 2, which is just 12 times 2, which is 24. All right. And number 12. This is our long leg, short leg. So our short leg is equal to the long leg over root 3. So 7 root 2 over root 3. And because we're not able to cancel those roots out, I'm just going to leave them as is. So now our short leg here, this is really the leg of the 45, 45, 90 triangle. So x is going to be 7 root 2 over root 3 times root 2, right? Because I'm trying to get to the hypotenuse being x. This is the same thing as 7 times 2 over root 3, 14 over root 3, which is 14 root 3 over 3, whenever you rationalize. And there we are. All right, that's multi-step triangle problem.